Find the acceleration reached by each of the two objects shown in the figure if the coefficient of kinetic friction between the 7 kilogram object and the plane is 0.250. So first, I drew my diagram. If the 7 kilogram object on the incline of 37 degrees and the 7 kilogram object, both objects attached via pulley. And then I drew my forces, which included the weight, which then I figured out the x and y components by creating the right triangle, and the angle there is 37 due to the incline being 37. And from there, I used geometry to figure out that the x direction is mass times gravity times sine 37, and the y direction is mass times gravity times cosine 37. I also labeled the normal force, which is upwards directly from the object, and tension, which is caused by the pulley, and friction, which is opposing that tension. I also labeled the forces on my 7 kilogram object with the weight directly downwards and tension directly upwards. You may also notice that the positive y is in the downward direction. So first, I found the forces on x, the 7 kilogram object, and I did that by equaling it to tension minus friction minus m1 times gravity times sine 37 plus m1 times a, and plugged in until I had 3 unknown variables, but I can solve for normal force. So I do that by finding the forces on y for the 7 kilogram object, which is normal force minus m1 times gravity cosine 37 equals m1 times a, and m1a times a is 0 because it does not go directly upwards. And from there I can solve for normal force. Then I plug in the normal force for that equation, and now I only have 2 unknowns, the tension and the acceleration. I then solve for the forces of y on the 7 kilogram object by doing m2 times gravity minus tension equals m2a, and plug in. Then I take the 2 expressions from the forces in the x direction for the 7 kilogram object, and the forces of y on the 7 kilogram object, and set them next to each other. And the tensions cancel out, as you can see. Do the math, and you can solve for acceleration.